Get started here. So hello everyone, and welcome to today's session in our seminar series on tracking technologies and their uses in migratory bird research and conservation. Thanks so much for joining us today. We have some great presentations lined up for the session, but a few quick announcements before we get into the presentations. Oops, sorry. First, we're going to have presentations given in both Spanish and English today. So here are the instructions for accessing interpretation in case you need them. And for our discussion at the end, please feel comfortable to use the language of your choice when you're speaking. And the usual Zoom reminder to please mute your mic when you're not speaking. Thanks so much. And for anyone who's joining us for the first time, this seminar series is hosted by the Migration Ecology Subcommittee, and we're part of the Partners in Flight Science Committee. And the goal of our subcommittee is to create a community interested in using tracking technologies to fill knowledge gaps around migration and ecology and inform conservation strategies for migratory birds. And we really hope that this will be an interactive space where people can learn about tracking technologies and how they can be used to answer conservation questions, and also a place to share experiences and brainstorm ideas and develop collaborative projects. And along those lines, we wanted to let everyone know that we've launched our collaboration spreadsheet. It's intended to serve as a space and a resource for developing collaborations around migration ecology and tracking, and for sharing funding and training opportunities to support these kinds of projects. So essentially, we want it to be a place where folks can go to find out about collaboration opportunities or can post projects that they're working on that have opportunities for collaboration. So we encourage everyone to check it out and use it. And we also have a place where you can submit feedback if you think there are ways we could improve its structure to make it more useful. And I'll put the links for both the spreadsheet and the feedback form in the chat. And finally, a reminder to join our listserv if you haven't yet, or pass it along to anyone who you think might be interested. And now we'll get right into the presentations. We've got 3 exciting talks today, followed by 25 minutes for questions and discussion. Since we have 3 presentations today, we'd like to ask everyone to please save their questions for the discussion period at the end. Of course, you can feel free to put questions in the chat throughout the session as well. And during the discussion period, feel free to unmute and speak or use the chat, whichever you're more comfortable with. And with that, we'll get into the presentations, and I will hand it over to my colleague Fabi to introduce our first speaker.
Buenas a todos.
Hello, everyone. It is my great pleasure to introduce you to Ana González, who is going to be our first speaker. I'm going to tell you a little bit about her background and her contribution to ornithology and migration as an investigator. She integrates behavioral and demographic field data with advanced tracking techniques to provide essential scientific information that supports both local and international conservation strategies for several neotropical migrants and conservation concern. Her research journey spans from her native Colombia to North America, covering the full annual cycle of migratory birds. Ana earned her PhD in 2018 and her master's in 2012 from the University of Saskatchewan, and she has held postdoctoral fellowships at Simon Fraser University and Environment and Climate Change Canada. Currently, she works for the Canadian Wildlife Service, where her primary role is to design and implement monitoring programs across national wildlife areas. A conservationist at heart, Ana remains deeply connected to research and conservation efforts in the neotropics, during her spare time. Her dedication and contribution to the field have been recognized through the Bio One Ambassador Award and the James G. Cooper Early Professional Award, presented by the American Ornithological Society. So without further ado, Ana, the floor is yours, and thank you for being here today. Good morning, and thank you so much for the invitation. For me, it's a pleasure to be here. I'm going to start sharing my screen. Okay, can you see my presentation? Fabi, can you confirm that you can see my screen? Yes, it looks perfect. It looks perfect. Okay, great. Good morning, everyone. Again, thank you for the invitation. Today, I want to show you the results of some projects in which we've used Motus, and I'm going to focus on how we can apply the information that we can gather with Motus to inform the information or to keep feeding the information for migratory birds and to be able to stop the decline in population in migratory birds. In order to do so, we need information at different scale, both in space and time, so we can identify changes in the migratory processes as well as in demographic processes of populations. Motus is a unique tool to be able to answer some of these questions for their year life cycle, especially for small birds, which are less than 30 grams, because it is a challenge to use technology to track them especially. And I can't. Okay. So today I'm going to focus on three of the main questions that Motus can help us answer. First, the factors that influence migratory decisions and strategies. The use of non-breeding habitat, especially during the winter, focusing on the type of habitat that these birds are using, the quality and the quantity that they require, and also I'm going to talk a little bit about more precise data to inform survival models, both seasonal and annual survival models. And this is with the use of Motus technology. I'm going to start talking about a project that is very close to my heart. In this project, we installed the first Motus antenna in South America. I think it was back in 2015. Here you can see it on the top of this mountain. We were working with Swice and Thrush in forest and shade-grown coffee in the Colombian Andes. We used Motus to detect local movement. We wanted to know the date in which the birds left each habitat and use it as a measurement for quality in the habitat, because previous research in the Caribbean especially, we had seen that the date on which they leave, it's a good indicator of the quality of the habitat. So we were hoping that the birds that left earlier meant a better quality. And if they left later, then the quality of the shade-grown coffee plantations, for example, was less. And here I want to highlight the power and the beauty of Motus. As you can see on the map, we didn't have that many stations. We had about 300 stations in North America. At the moment, we have over 1,000, and we still didn't have any on the west side of North America. So we started putting the tags on some individuals to see if they were detected in North America. We didn't see it possible, but it did happen because we were very happy that we found them in 4 regions in Central America. Sorry, in the central part of North America, on the coast of the Gulf of Mexico, and the northeast of North America. These international detections allowed us to have an idea of the impact of the shade-grown coffee plantations and the migration strategies of these birds. I'm going to show you an animation where we can see the individuals leaving our site of study and flying to their breeding grounds and how we can detect them throughout the Motus network. Here we can see the date, and in the next graph, I'm going to show you some outcomes related to the speed of migration and the different regions in which these birds were detected in North America. So, Motus allowed us to answer our first question about the date on which the birds left. We found that the birds that were spending the winter in shade coffee plantations left earlier than those that were spending winter in the forest. This is opposite to what we were expecting, and we found that, well, in this graph, you can see the date on which they left Colombia, and here we have the days after they left and how long it took them to arrive to each of these regions. Here is less than 10 degrees. This is still South America, how long it took them to get to the Gulf Coast, to the Great Lakes, and to Quebec and the north of Saskatchewan, which is over 47 degrees. We found that opposite to what we expected, the birds that left earlier, sorry, that the birds that left later took less time to arrive to each of these regions. So they left later, but they traveled faster. So this negative relationship between the date on which they left and the speed of migration was sustained on the arrival of each of these regions. So with this, we were able to prove that the wintering habitat, both the forest and the shade coffee plantation, affect migration strategies of birds in terms of the time of migration, phenology, and also the efficiency. And we found that birds that leave later leave a habitat that has a better quality, and they arrive almost at the same time than birds that left earlier. So this is a new observation that we found in migratory strategies, because what was widely accepted was the opposite, that the birds in the best habitats leave first, and they arrive first to the breeding sites in North America, therefore having a higher success in breeding. But we found that those that spend winter in the forest can catch up with birds that left earlier from the coffee plantations. So from Colombia, we're going to travel to Canada. I live and work in the province of British Columbia, in the west of Canada. Most of my monitoring program is in the Okanagan Valley, which is unique. It's a dry valley. It has over 44 species at risk in Canada. These habitats represent less than 1% of the area in the west of Canada. And these habitats have a lot of threats, especially because of development, agriculture, and river channelization for agriculture. We don't have a lot of habitats like these left in this area, and we are using a very similar system to the one in Colombia. We are tracking 2 species, the veery and the willow flycatcher. The detections have been incredible. We have found over 95% of the individuals that we have tagged using the Motus network. This is where we placed our tags. And even though these species are in the same protected area of British Columbia, they use completely different routes. The veeries are migrating towards east, while the willow flycatcher are migrating south, and they're spending the winters in Mexico. The veery spend the winter mostly in the Amazon, and due to the limitations of Motus network in Latin America, we don't have further detection after Colombia. These are preliminary results, and we still need to analyze the different factors that are having an impact on the dates when they leave and also the migratory capacity. So the idea is to overlap the Motus data with spatial data to identify where the riparian habitats are, which are critical for the survival of these birds, and to start thinking about recommendations like expansion of protected areas or the restoration of riparian habitats. Now we're going to move on to the second questions, which is how they're using the non-breeding grounds. These questions have been approached by different researchers, and not only during the winter, but also during migration and during the breeding season. So in this project was done with the Canada warbler in the Colombian Andes, in the central mountain chain, the east and west mountain chains. We captured warblers at the 3 sites, and we used Motus antennas to get data for our survival models and to determine if the species was present at the site or not. And we were also using manual telemetry to be able to estimate the range of presence of these species. We identified 109 individuals, and this was from January to March, and we had a home range size of 34 individuals, which is about 10 per site. With this information, we determined the effect of precipitation, habitat quality, and habitat availability on the home range of the species. This paper is on review at the moment, and we observed that the precipitation during the tracking period and precipitation prior to the tracking of these individuals during the non-breeding season affected the home range. And when we had lower precipitation, then we had smaller home ranges. And this includes precipitation during tracking and prior to tracking. So we found that there was an effect due to precipitation, and we also estimated the NDVI as an indicator of habitat quality within each home range. And we found that when this habitat quality is higher, than the smaller HR or home range. We also observed the habitat availability, and we found that this correlation between home range and availability is different depending on the sites. So, for example, here we have the west and the central part of the Andes, which are areas with a high rate of deforestation, and we found that when we have more forest around the home range, then the home range tends to be larger. And in the east, of the Andes, where we have more forest, less fragmented forest, less deforestation, then the more forest, then the smaller HR. And likely the quality of the habitat is higher, like we found with the NDVI, and they are having a higher density within these forests that are not as fragmented as in the west or central part. And I'd say that one of the most important results that we have found with this project, I think it was that we could determine the size of the home range, and this information we used was used for the investment strategy for three migratory bird species. We used the home range information to determine uh, how much habitat we needed based on the habitat that the birds needed during the winter to at least keep the population stable or increase it 5%. So this is a recurring question. Why do we need to know the amount of habitat being used by the birds? And the answer is because we need to find the home range. And so this is a very ecological question, I think. But if we want to know the amount of habitat these individuals need, and we want to get data for an investment strategy where we give a budget to know exactly how much conservation will cost us, all of these estimates can only be done if we know the amount of habitat and the type of habitat these species need. Otherwise, we're just going to be assuming or imagining the information if we don't have the baseline. So, moving to the end of the presentation, we have used the Motus network to inform the encounter history that we use for our survival models. And we have used this for a couple of species. There is a lot of data that has been published. We have used Motus, for example, to improve the estimates of the overwinter survival in forest for the Canada warbler, and also to gather data about the annual survival in forest and shade-grown coffee for Canada warbler and the Swanson's thrush. And we are working with other species to be able to have both estimates. So seasonal estimates, the survival rate of a species, let's say during the winter or during migration or during the breeding season, or also what is the annual survival. And the use of Motus network and manual telemetry, the combination of both, is a very powerful tool to analyze survival rates, because one of the biggest limitations that we have is that when we carry out these analyses, we don't actually know what is happening to the birds, if they actually died or not after they were captured. We don't know if they are still alive, so we can do two things to have data for this model. We can first report the rate of mortality whenever we come across dead individuals. We can also look into detections. Maybe sometimes we lose an individual during the breeding season, but when we see our Motus network, we realize that that bird has migrated. It was alive when it left, or we can also find it in the international network, and that way we can confirm that the birds were alive. So That is one of the strongest benefits of the network to estimate survival rates. And I want to wrap up my presentation talking about a project we kicked off a couple of years ago in Mexico. There we are applying everything that we have learned from Motus. Here on the photo you can see the Motus antenna and the terrace of the city hall in Oaxaca. And this is something very similar to what we did in Colombia and Canada. We're using Motus to estimate the survival rate during the winter and annually as well. We are looking at the habitat use for the area beatings, and we're also estimating home ranges, and we hope to have information on the migration ecology as well. And I want to thank Sergio Gomez Villaverde, who's the person in the photo, because he is the leader of this project in Mexico. This is the area where the yellow-breasted chat spend the winter. These are riparian forests, and I'm going to leave you with the results of this project, so maybe we can have a presentation about it in the future, because it's very interesting to see the relation that we have found in the habitat and the corn fields. This is a field that is completely clean. It's not used by the chats at the moment, but as soon as the corn grows, it becomes a key habitat for the winter season for the yellow-breasted chat. So the take-home message from this presentation, I'd like it to be is that first we start with simple questions at a local level. In the case of our projects, that's how we started, and Modus allows us to answer questions at a larger scale, even continental scales. And collaboration definitely is key to be able to have these type of projects and to keep the network alive and to maximize funding. A key aspect has been collaboration and creating capacity at an international level. I want to highlight the work of everyone working at the field, because they are the stars behind all of these projects, and sometimes they don't get enough acknowledgement during these presentations. I want to highlight some people specifically who are doing their master's or their PhD in North America using Motus. They started as volunteers in my project in Colombia, or they were working as biologists. Here's Catalina from the University of British Columbia. Ana Maria did her master's in the University of Saskatchewan. Now she's working in Ottawa for the Canadian government. Agata Kawasango has been fundamental for the development of the Motus network in South America. Denise Cardona, she just arrived to Canada, to the Bird Observatory of Ontario. Pilar started as a volunteer in my project, and she's currently working in her PhD in the University of Western Ontario. And Sergio Gomez, who is now leading his project in Mexico. And Jason Sanabia, who we all know is one of the stars of Motus in Colombia, and well, for ornithology in general. So I want to thank all of them, and a lot other people that I don't have time to mention. I want to thank them from the bottom of my heart. And I forgot about Julie. And I want to thank all of my mentors. I want to dedicate this presentation to the memory of Keith Hobson, one of my mentors. He was one of the first people that believed that Motus could work in South America, and one of the first researchers in North America that supported the study during the non-breeding season in the northern of Colombia. To Nick Bailey from Selva, Scott Wilson from the Canadian government, Wendy Easton, and Stu Mackenzie from Birds Canada. We've received support from a lot of people, so I want to thank all of you. I forgot the slide of the organizations. And well, I'll be very happy to answer any question that you have at the end of the presentation. Thank you.
Muchas gracias, Ana. No sé si Fabi
Thank you, Ana. I don't know if Fabi is in. Is there?
Okay.
I'm so sorry. Thank you so much, Ana. Thank you for your presentation, for sharing. And we're going to answer the questions at the end. You can leave them in the chat, or you can keep them for yourselves and open your microphone at the end of all the presentations. And thank you. I'm going to leave the floor to Ana to introduce us to the next speaker. Thank you, Ana, for your excellent presentation.
Jeff Ritterson, who is going to talk to us about using radio telemetry to inform forestry practices for wintering wood thrush. Jeff is a field ornithologist with Mass Audubon, where he's responsible for land bird conservation, including full annual cycle initiatives. He directs the Massachusetts Foresters for Birds program, which generates information on bird responses to forestry treatments and communicates these relationships to practitioners and landowners. Jeff also has extensive experience with wintering neotropical migratory bird research, including work with a marked population of golden-winged warblers in Costa Rica, to understand the relationships between survival and habitat selection, and developing quantitative habitat thresholds for supporting tropical avian forest communities. So take it away, Jeff.
Thanks, Anna. Just getting my screen shared here. And how we looking?
Looks great.
Great, thanks. And good afternoon. Great to be here. Thank you all for being here, and what a fun topic to talk about. Y hola a todos, soy Jeff. Gracias por estar aquí. Entiendo bastante español si alguien
Hello,
quiere
everyone. I'm Jeff.
escribirme en español después de esta reunión está bien, pero hoy
I
día hablo en
understand
inglés.
Spanish very well, so if you want to write to me in Spanish after the presentation, that is great.
No tan bien. Pero, okay. Okay, so here's the star of the presentation, the wood thrush bird many of us know and are fond of, whether on a breeding territory, actively migrating, or during the stationary non-breeding season. But it's also a species of conservation concern. Right, so on the left are eBird status and trends data covering about the last 10 years, and it does in fact show an increase in abundance throughout much of the wood thrush's breeding range, both with a decline in the northeast and after decades of sharp decline. The breeding bird survey also shows that change in range-wide abundance, which is encouraging, but we used to have a whole lot more of them, right? In fact, it's a species highlighted by the landmark 3 billion bird study, with 6 in 10 wood thrushes gone since 1970. So wood thrush remains a priority, with it being considered, for example, a tipping point species by Road to Recovery, a Partners in Flight watch list species threatened in Canada, and so on. And I believe wood thrush is a great umbrella species for the conservation of other forest birds on the breeding grounds and possibly during the non-breeding season as well. And we know quite a bit about wood thrush during the breeding season. Here's just a small sample of papers covering topics such as nesting behavior, reproductive success, survival, demographics, and more. And while there's always, of course, more to learn, much of this information has been synthesized into guides for practitioners, and we have management practices and conservation programs underpinned by all this science. And we have some information on migratory routes and connectivity, for example, using stable isotopes and geographic variation in wing length, led by Clark Rushing on the left, and a geolocator study led by Callie Stanley on the right. And more coming from the Wolf Party project, more formally known as the range-wide wood thrush tagging project led by Sarah Kendrick at U.S. Fish and Wildlife Service, Nick Bailey at Selva, where hundreds of nanotags are being deployed across most of the breeding and non-breeding range of wood thrush and tracked via the Motus network. So exciting times, and sure to provide more information on connectivity, survival, and other great things. During the stationary non-breeding season, we know habitat associations for wood thrush, right? Primary forest, secondary forest, some agroforestry systems, excuse me. And we know a bit about where they're more abundant and different rates of survival. Interestingly, they apparently sometimes occur at high densities in habitats where they have low survival. For example, in Honduras, Brett Bailey and Dave King found the more time wood thrush spend in heavily shaded coffee, the less likely they are to survive. They get eaten by predators. So it's important to consider metrics besides abundance. And then wood thrush can exhibit different space use strategies, with some being territorial and others non-territorial, often termed floaters, with links to survival and habitat quality as well. One thing that is missing are studies examining a range of habitat conditions, or more specifically, avian response to forest management practices. The same sort of studies that underpin the guidelines and programs that I mentioned on the breeding grounds. And the very new conservation investment strategy for birds of the Caribbean slope identifies wood thrush as a focal migratory species. And among other strategies, there's a call for scientific research on resident and migratory birds and the development of sustainable and bird-friendly production practices and programs as an alternative to intensive agriculture. And so the project I'm about to introduce directly addresses both of those strategies. And our study site, shown by the red square here in Belize, is within a key biodiversity area and a priority site as identified in the investment strategy. And the project is titled Forestry Standards for Non-Breeding Migratory Birds, and is funded by the Neotropical Migratory Bird Conservation Act, administered by the U.S. Fish and Wildlife Service. So a big shout out to them and the invaluable work that they do. The main partners are Mass Audubon, Dave King from the U.S. Forest Service, Northern Research Station, and Program for Belize. We were also able to bring in Abita Sash from University of Belize Environmental Research Institute as a partner. And the idea is that sustainable logging programs may be a land use that conserves biodiversity while also generating some economic activity. It can be practiced over a large area, and unlike many agroforestry systems, it maintains native vegetation instead of replacing the understory with a crop species. And there's evidence that this type of logging is relatively benign to biodiversity, but studies to date have largely looked at logged versus unlogged areas and not that range of conditions. They've only looked at metrics like species richness or abundance, and not performance-based metrics like survival, for example. And they haven't looked specifically at migratory birds. And despite the title of the project, we are collecting data for all species, migratory or resident, so we can assess the impacts and develop forestry practices for the entire community of forest birds. And so Program for Belize is an absolutely amazing organization. Mass Audubon has a decades-long relationship with them, and we worked closely in co-developing this proposal. And they own and manage a 100,000-acre Rio Bravo conservation management area outlined in red here. And that land is heavily forested and protected from being cleared, which is important because deforestation, of course, is a big driver of declines. On the top is a photo I took while driving along the border of Rio Bravo, and the bottom being a satellite imagery along the same part of the road. The agricultural land on this side was forested as recently as 7 or 8 years ago, with more land being cleared in the area, likely as I talk. So it's a real threat. Program for Belize manages Rio Bravo under an agreement with the Belizean government for biodiversity conservation and sustainable development. To that end, they run a sustainable timber program on about a third of this land, shown in yellow. And only about a third of that area has been harvested in recent decades under their program. And so all the small dots on the right here show the location of harvested trees within this 100-hectare compartment, which is all these squares shown here. And the darker shaded areas show a higher density of trees removed per hectare. And so a gradient of harvest intensity exists and provides a natural experiment of sorts. And it's not high intensity logging, but rather the selection of single trees to be harvested with relatively little disruption, but enough to create some dense growth in the understory, the exact conditions that wood thrush, in other words, may in fact prefer. And so we just wrapped up the second field season of a 2-year study, and part of it was a constant effort mist netting study at 20 sites across that gradient of logging intensity. And from this, we'll look at metrics like species richness, abundance, age and sex ratios, and performance-based metrics like change in body condition over time and survival for as many species as we can. And then there is the radiotelemetry derived metrics for wood thrush, which I kind of think of in 3 or 4 categories, being fine scale movements, such as habitat selection, during which time you may also be able to do like behavioral observations. Then local movements with metrics like home range size and space use strategies. And migratory movements, things that we traditionally think about using the Motus wildlife system for, right? Like departure dates, migration speed. And I might suggest adding a 4th category of regional movements, particularly during what may be a post-breeding or pre-spring migration period. And I'll say more about that later. So for fine scale movements, we deploy 57 low-tech nanotags over the 2 seasons across that same gradient of logging intensity, and manually hand track the birds to characterize fine scale habitat selection. And from this, we can also estimate survival. And so this is all great and I think successful so far. Okay, local movements. The different colors of dots on the left here show locations for 3 wood thrushes obtained by manual handheld telemetry. And so we can maybe start getting a sense of home range size, perhaps space use strategies, but this is sensitive to the number of points you have, right? And we got very few points from some individuals. If you look at the literature, wood thrush home ranges are estimated to be anywhere from 0.1 to 13 hectares. But I suspect even larger at times. Meanwhile, we tested the range of our manual receiver in the forest, and it was about 160 meters. So we ended up with a 43% chance of going out and relocating a radio tagged wood thrush manually. For migratory movements, our tags, last approximately 380 days, which would include both the spring and fall migration. I haven't downloaded Motus data recently, but 6 of the 26 birds we tagged during our first season were detected at stations in North America. 7 detected returning to Rio Bravo the following season, which is great. As Anna just discussed, it tells us these birds are still alive, and we'll be interested in working that information into survival estimates. To determine spring departure dates, which may be related to habitat quality, we set up 3 Motus towers to form a gate around the study site, all with 9-element Yagi antennas, which the birds would have to fly through these detection lobes when leaving on migration. 1 tower went up at Hillbank Field Station, our main sort of study area within Rio Bravo, shown by the green star. Another at La Milpa Ecology, which is another program for Belize site in the northwest of Rio Bravo. And these 2 towers here and this lobe down here were pre-existing and are managed by other folks, but provide additional coverage. And a 3rd tower was set up here at a local grade school in the town of San Felipe. And I just have to mention that this provides an excellent education and outreach opportunity. And in fact, a wood thrush tagged in Costa Rica was detected at their school and at a school in Pennsylvania. And these kids from the 2 schools are meeting each other next week on a Zoom call. So just really cool stuff. And love to tell you more about that at at some point. Anyways, birds were tagged and relocated with manual telemetry at these locations during the 2023-2024 field season. And looking at plots of radio signal strength over time, you expect to see a parabola-shaped pattern as birds fly perpendicularly to the antenna, or more of a straight line, right, as they fly parallel to the direction in which the antenna is pointing. Well, we got nothing. We detected no clear departure dates. So at the beginning of the 2024-2025 season, we redirected one of the antennas from this dashed lobe here to this direction, directly over where we would be tagging birds. This way we could monitor birds potentially during the season with the Motus tower and try another method to get departure dates, which in this case would be indicated by a sudden change in radio strength signal as birds fly up over the canopy and then through the other detection lobes of the surrounding towers. And here are the places where we tagged birds during the 2024-25 season, and well, we got nothing. No clear departure dates. We did have birds detected by the Motus tower periodically throughout the season, but not continuously detected, very likely due to the very dense forest cover that they reside in, spending a lot of time on or near the ground. And we've detected loads of other individuals at our towers, somewhere around 100 tags, I believe, so the towers are working. Well, again, non-breeding wood thrush are known to be wide-ranging and move a lot, and this behavior seems to pick up as we approach spring migration. On the left, I'm showing you how our probability of relocating a bird with manual telemetry drops from 0.54 before March to 0.22 during the month of March. And on the right, we see the number of detections on the Motus tower jump up in March. So it seems the birds are moving more come March. Any established territories may be dissolving, and maybe the birds are experiencing Zugenruhe, right? That is migratory restlessness or the urge to make some sort of movement. And then using radio telemetry and GPS tags, Callie Stanley et al. Found the proportion of stationary wood thrushes decreases over time. I added these vertical lines in the figure denoting March 1st myself. And they also documented permanent mid-season relocations of wood thrush up to 148 kilometers with links to moisture and body condition. It's a really cool paper. And so this is why we may need to be thinking about regional movements or a post-non-breeding pre-spring migration period as part of this full annual cycle conservation. And so we tagged birds in the area around the green star, right? And if they departed directly from this area and above the canopy on spring migration, we might expect to have detected them on this antenna, not to mention all the others. Instead, maybe they're moving through the forest below the canopy and outside of this detection area. We're making short above canopy flights. If they were to head north, northeast, or east, they would run into extensive agricultural lands and maybe some pine savanna and be forced to fly or otherwise detected by the Motus towers. So instead, perhaps they remain tied to the forest and move west into Guatemala. And the geolocator study I mentioned found that many wood thrushes move up the Yucatan Peninsula before flying over the Gulf, while some may go around the Gulf. But here you can see the large continuous forest block that is the Selva Maya forest extending up the Yucatan. And if wood thrush either continue drifting under the forest canopy or make several shorter flights and stops as Canada warblers do, they would remain tied to the forest, right? And this seems like a good route to take. And so here we are with a species that remains a bit cryptic, even when radio tagged, and escaping reliable detection from traditional Motus towers, and not so straightforward to manually track either, which makes it difficult to estimate home range size, space use strategies, and departure dates. However, researchers are having success using arrays of Motus stations, or more generally, automated radio telemetry stations, right? Wouldn't necessarily have to be connected with Motus, but often they are and probably should be. But anyways, these arrays are arranged in relatively close proximity and often using antennas with shorter detection ranges to gain better spatial resolution or to determine if a tagged animal is detected, for example, in discrete areas of a study site. And to be clear, I'm completely new to this, not an expert at all. And in fact, this is my first Motus project entirely, so wide open to any feedback on any of this. But this is kind of where things are leading me. So, for example, the red starts in Jamaica have been such a great model species. And here they are again, Dossman et al. Deployed omnidirectional antennas with a range of about 300 meters, shown by the gray circles, to detect the presence of red starts across parts of this 40-hectare area. And we're able to distinguish between territorial individuals and floaters in this way. And Jenny Smetzer et al. Have had great success with automated radio telemetry networks in Hawaii. For example, they are able to identify movement strategies and develop kernel density home range estimates using 12 automated telemetry stations, each with 6 directional antennas, right? Doing things like triangulation or all sorts of crazy statistics to get relatively accurate positions. And they had antennas below the forest canopy and were able to detect birds also below the forest canopy with a median range of 0.7 kilometers or a max of 2.7. And so this all sounds amazing to me. And applying something like this to the effects of logging on wood thrush, we could, in theory, get better home range estimates instead of these few points here. Maybe it's all the way over here as well. And understand how much time they are using in areas differing in harvest intensity and relate that to, of course, performance and habitat quality and to logging and silvicultural prescriptions for conserving wood thrush and other birds. And there are a few private and gated roads along which we could set up stations, including one to the west, which could help determine if wood thrush are indeed heading that way during migration. Or is it post-non-breeding regional movement? I don't know. Anyways, to date, I've done absolutely no thinking on how feasible this actually would be, how many towers would be needed, budget, nothing of the sort. This is just me sort of dreaming and throwing ideas out there. But sometimes that's how cool things happen, right? Okay, so just a quick thank you to the many people and partners involved in this and to the Fish and Wildlife Service for funding. It's been loads of fun to date. And here is my my contact information if folks want to reach out, and we'll take questions after the next presentation. Thank you.
Thank you so much, Jeff. That's an awesome talk. And I loved the plug for more Motus towers in the Guatemalan Mayan forest. Yeah, definitely we'll have to connect more about this project. Would love to replicate some of that stuff over there. Yeah, all right. Next, last but not least, we have Kristen Heath-Acre, who is going to be talking about tracking local movements of brown-headed nuthatch in Missouri. Kristen is the state ornithologist with the Missouri Department of Conservation, where she currently leads the reintroduction and monitoring of brown-headed nuthatches in Missouri. She holds a master's from Texas Tech University, where she researched population trends of the snowy plover using Motus data. Kristen has worked in diverse ecosystems from Panama to the Texas Plains and supports Missouri statewide bird monitoring outreach and habitat restoration efforts. Take it away, Kristen.
All right, thank you. Can you hear me all right? Great.
Yeah.
Yeah, well, first, thanks for inviting me to talk about this. I'm really honored to be talking to this great group of people and listening to these, watching these awesome projects. I'm talking about some local movement tracking rather than sort of hemispheric tracking as we sort of traditionally think about Motus. So this is sort of a flip on how we usually use Motus, but I think it can be very helpful. So we reintroduced a population of brown-headed nuthatches to Missouri, and there was sort of a pilot effort in 2020 and 2021, and I have continued this effort in 2024. And so we don't have a lot of analyses or conclusions to share today, but I will talk about the background of the project. And I'm going to go into a little bit about the preliminary results and how we're moving forward with the project. So yeah, talking about the reintroduction, background, the translocation, and then going into more specifically the local scale tracking using Motus. A little bit about brown-headed nuthatches, very cute bird, small songbird, about 9 grams, and they're a pine woodland obligate, so you only find them in pine woodland. They're a resident bird, so non-migratory, and they're a cooperative breeder, so it's an interesting life history trait of this bird. And they're common and widespread throughout their range, so you find them in the southeastern United States. Here you see an eBird abundance map of brown-headed nuthatches, and you see lots of dark purple. So wherever you find brown-headed nuthatches, they're not listed on any state or federal threatened or endangered lists, which was important when we were considering their candidacy for reintroduction. They need open understory pine woodlands again. They need mature pines for foraging. So nice big old pines, not the newer ones, the younger ones. And they need well-decayed snags for nesting. So they're a primary cavity excavator. They excavate their own cavities. And so they need a real soft substrate because they don't have a big woodpecker bill. They like broken off pine snags, and they like really well charred, decayed snags like this one. This is a nest that I'm checking. They were likely extirpated from Missouri in the early 1900s. There are 2 records of them in 1907, but because of really intense logging activities during this time, we likely lost them. So shortleaf pine oak woodland systems once covered, some estimates say, up to 6 million acres of the Missouri Ozarks. And this bird likely lost or left the state when these pineries were removed. These are some historic photos of those pineries being removed. They could clear as many as 70 acres a day. So it was a really short-term, intense logging effort that made this habitat disappear, and likely the brown-headed nuthatch and the red-cockaded woodpecker as well. This is a historic range of shortleaf pine, which is the only native pine to Missouri. And this is just to show that we do have shortleaf pine here in Missouri, but we don't have as that structure, that pine woodland community structure that brown-headed nuthatches need here in Missouri. And so habitat restoration was a really big part of this project and what made this project possible. And that was made possible in part by the Collaborative Forest Landscape Restoration Program. Lots of words for a lot of money dumped into restoration at Mark Twain National Forest, which is where our reintroduction took place. Over 60,000 acres of habitat has been restored, and there's more money that has been allocated for this effort in 2022. And so that's very exciting. But brown-headed nuthatches are a resident bird. Of course, they make few long-distance dispersals, and so natural recolonization of this restored pine woodland was unlikely. And so that's where this idea of reintroduction came from. And I'm fast forwarding through lots of analyses, justification for reintroducing brown-headed nuthatches. We did habitat suitability analyses. We did calibration surveys, calculated carrying capacity of this region. And so I just don't have time today to go into that, but wanted to say that we did our best to justify the reintroduction of this bird to Missouri. So phase 1 of the reintroduction happened in 2020 and 2021. We translocated 102 birds total, and we used radio telemetry, traditional radio telemetry, during these first 2 years. So hand tracking, each tag was on a different channel or frequency, no Motus tags or towers. And we took birds from Ouachita National Forest in Arkansas to Mark Twain National Forest in Missouri. A little background about how we did this, because it's pretty interesting. We used elevated mist nets because these birds are kind of high canopy birds, tough to get low to the ground. So we put the net poles on painter's poles, extendable painter's poles. We used con-specific playback and decoys to lure those birds into the nets. And we've gotten better at doing that every year. As you all know, each species has its own challenges, and you learn about how to capture them best. And once we extracted those birds from the mist nets, we put them into 4x10-inch mailing tubes, like you see here in this photo, with perches at the bottom and tulle fabric covers so that they were nice and breathable. And we gave them all 4 to 5 mealworms as a sort of in-flight snack. And we flew them first class using a small MDC aircraft, and in total about 5 hours total transport time. So that was the name of the game, is to reduce stress to these birds, keep transport time very short, and I think we were as successful as we could possibly be. So kind of looking at it again on a map where we released these birds in 2020 and 2021 down in the 11-point district of Mark Twain National Forest, which is, you can see there in green. Now we're zooming in. So this is the release site. And all of these blue dots that you're seeing are radio telemetry resites. So using hand tracking, this is where we found the birds during those first 2 years. And I wanted to show you this because it provides good context for where we put the Nuthatch pop-up stations in 2024. So we chose high elevation sites in clear canopy areas, and we put up these 20-foot pop-up Motus towers. They are solar powered, and we used 5-element Yagi antennas, 4 of them pointed in 4 cardinal different directions. And we used 5-element antennas because we really wanted to get depth of detections rather than range. I thought if we used 9 elements, first it would be heavy for a pop-up station, but I was afraid we would lose that depth of detection. And we tagged 30 brown-headed nuthatches out of the 95 that we captured last year. And so, you know, this was an effort to really track these birds more continuously, because in those first 2 years, we really had issues with birds disappearing, and we didn't know if those birds, died or just left the search area. And so we wanted a finer scale detection rate to get at that question of whether these birds are leaving, because while we could hand track them, this is a very large area for 2 or 3 people to hand track. And we weren't that successful finding birds well outside this kind of core area. The tags that we put on these birds were 19-second burst rate, so really spread out burst rate. We had on-off programming, so they turned on at 6 a.m. in the morning. And we're really trying to draw out that detection or that signal's battery life. So this gave us relatively 3 to 4 months of tag life, which was great for such a tiny tag. And we did calibrate it with some hand tracking to compare those detections to the tower detections. And this is what we found. We kind of gleaned a lot of information from just those 6 towers. What you're seeing here is an abacus plot of detections. On the y-axis You have individual tag ID. So each of these lines is an individual. And each of these colors indicates a different tower. So you have 6 different colors because we had 6 different towers. We tagged 30 birds in 2024, and we detected 28 of those birds. So I suspect that 2 of those birds' tags did not work because we never detected them at all. And right off the bat, you can kind of tease out some patterns. First of all, some birds parked by a tower and thought, this is great, we're not leaving. So a few birds were detected continuously throughout the whole tag life. Some birds bopped around a lot. I'll highlight this bird here in a little bit, but it visited all the towers very, very frequently before kind of settling down with another bird to which you can see here. So that's another point that I was going to make. You can see how these birds pair up. Here, you can see that here, these birds are clearly in some kind of family unit or partnering up, which is really interesting to see. You also have birds that left and came back for brief periods. And I think this is one of the most important aspects of these Motus towers because they are continuously recording and detecting these birds. And this is something that we likely would have missed by hand tracking. So this detection here in the middle, we probably wouldn't have picked that up. Same with these detections out here. And so this really gives us a better breadth of knowledge to hopefully help inform survival models in the future, which is important to know for this reintroduced population. And then we have birds that left and we didn't see again for the rest of the kind of the detection zone, if you will. But I want you to keep these birds in mind because they do come into play here in a little bit. This is just a zoomed in version of that bird that bopped around a lot. Tag, what is it, 583? And I think this says a lot about sort of, this is a new bird and a new habitat. It's exploring, it's figuring things out, but it eventually settles down. And again, this bird actually settled in with another bird. So potentially moving these birds in family units is important when we're talking about these movements. And we also did look or did find that these birds sort of wake up around sunrise or about 15 minutes after sunrise. This was sort of an interesting aspect of this project. I never really wondered when nuthatches wake up, but here we go. And this could potentially help us with programming of ARUs, when to start them, if you're specifically targeting brown-headed nuthatches or looking at survey protocol in the future. So there's some more interesting information you can get from these towers. And another important aspect of this is sort of what we did not find. And this is another reason why I wanted to use Motus towers, because I wanted to potentially find mortality events. And I knew that this was possible because of work that Selva has done, and Nick Bailey and Selva graciously allowed me to share these slides. But you can detect when these birds are predated. And I think Anna showed this as well. But this is an adult female cerulean warbler. It is surviving the winter and migrating at the end. So there's lots of variation in the signal strength at these 2 towers that this cerulean warbler is being detected. This is a bird that's predated. At first, this male cerulean warbler was nice and active, and then that signal strength disappeared and reappeared as kind of a low level signal strength of a tag that's clearly not moving. And they were actually able to retrieve this tag and the leg bands, but not the bird. So of course this bird was predated. But this is sort of the information that I was interested in potentially finding. We did not find any evidence of mortality events, which I thought was interesting. Now backing up again to sort of this landscape level view, I wanted to talk about sort of some outliers that we detected not using Motus. And so if you recall those birds that I highlighted earlier, those are those birds. So this dot, this western dot is 2 birds, and this one is just 1 bird. But these birds left the detection zone of the Motus towers. So there, of course, are limitations here. And, it's not necessarily surprising because there is managed habitat, managed pine woodland up in this area. So tree thinning, and prescribed fire, which is needed to kind of recreate that pine woodland community and structure to open up the understories, to open up the canopy. That is happening here. And so I'm not surprised these birds are moving that far north. And we detected these actually using a helicopter telemetry survey. So we had a 5-element antenna attached to a helicopter that we were able to fly over the area and find these birds. And as a result, we were actually putting a Motus tower up near this area for this year's tracking. And this is 9 miles or 14 kilometers. So these birds flew a pretty good ways in just a month or 2. Now this bird up here was detected at a Central Hardwoods joint venture field trip or field visit by a bunch of scientists who were meeting about something entirely different, and some brown-headed nuthatches started to call and sing above them. So that was really great. This is a little patch of managed habitat by a nonprofit. And so that was really exciting that they got nuthatches, even though they're 27 miles away or 43 kilometers. But these birds were likely from the earlier cohorts, so 2021 birds. So we're filling a bigger cup than we previously thought. We were really focusing on restored habitat in this core area, but I think that these birds are finding patches of good habitat elsewhere readily, which is, I think, encouraging. And these are Motus towers that are already existing, but we actually just put up this tower that I'm pointing to, and it is really going to be focused on these brown-headed nuthatches, but also we're using them, we're trapping wood thrush around them here in a week. So that's pretty exciting. And again, we attached 5-element Yagi antennas to hopefully get at that breadth of detection. They have a wider detection, I forget what it's called, angle. And so it can get at those ground detections more easily, hopefully. And so the whole point of this project, in addition to reintroducing this population to Missouri, is we want to improve estimates of survival using these immigration rates that hopefully we can extract using these Motus detections. Identify which birds are moving and where. It reduces hand tracking expense, and it really increases those detections, which you would likely miss while hand tracking. And we have expanded this year by adding that taller station. That station is on a fire lookout tower, and so it's much higher, and I think we'll get much better coverage for those birds that are moving northward. And one other exciting thing, I also included a WATH party plug, but our Motus stations were active during fall migration, and we picked up 5 wood thrush from Iowa and Missouri, and I think Minnesota as well. And that was just really exciting. A lot of it was because all of these birds were detected together, even though they were tagged in different places. And so that's just exciting that this happened. And in the future, after this Nuthatch project is over, I plan to leave up a couple of those towers indefinitely to hopefully get at these migratory movements, because we suspect that the Ozarks are important stopover habitat for wood thrush and for other birds as well. And that's all I have today. This QR code goes to a Forest Service podcast, and it's a background story about the brown-headed nuthatch reintroduction. It's very good. And if you like this project, I encourage you to listen to this podcast. It's about 40 minutes. And yeah, thanks. And I think happily we'll take questions when that time comes, and I appreciate the opportunity to talk.
Thank you so much, Kristen. That was so cool. I love like the different styles and scales of tracking and like using the handheld telemetry to inform where you put the Motus stations and then finding them from the air. Very, very cool. Yeah, thank you to all of our speakers for some amazing presentations. We only have about 15 minutes left for questions and discussion. But yeah, feel free to put questions in the chat or feel free to raise your hand. And as usual, you can ask questions in English or Spanish, whichever you're more comfortable. Let's see. Okay, well, the first question I'm seeing is from Russell. For Kristen, can you speak to the relative costs of hand tracking versus a dense temporary Motus network?
Yeah, so the sort of a small array of pop-up towers is not cheap necessarily. So when we're talking about, paying technicians to be down there for 2-3 months, I think, equivalent, you would need a crew of people down there for the equivalent amount of time. I think it kind of breaks out to be even, depending on the effort you're doing. But what you get is some much better detection, sort of, you get a better breadth of detections. And so I think the payout is better for the Motus network. And we put out, I think you could do it cheaper, essentially. Possibly fewer towers or fewer antennas or smaller antennas. And I think it would really depend on the habitat. We sprung for 5-element antennas when, if it's a much more open habitat, you might not have to do that. So it really depends. And you might be able to get away with 3 towers instead of 6. So we had sort of dense habitat, we had to kind of go under the canopy. And so it was definitely a trade-off, but I think the payoff was much better with a Motus array.
While we're waiting for other folks to put questions in the chat, I have kind of a general question for any of the speakers, actually, which is just if you can speak a little bit more to beyond cost, kind of some of the trade-offs between hand tracking versus using Motus to look at local movements, and also challenges, if any, with like integrating them. Things like tag type, like can you use the same tags for each, and yeah, any other sort of challenges with doing both on the same species in the same landscape.
I initially anticipated you hear stories of wood thrush often moving together, and I had nightmares of having a bunch of tagged wood thrushes moving together and not really being able to not decipher who's who, but to home in on one with manual telemetry. Relatively easy enough to find them and do some habitat measurements from there, but we didn't necessarily experience that. And once you get that gain cranked down pretty far, you can readily distinguish one from another, unless they're like right on top of each other, it seems.
Yeah, I think also the benefit of not hand tracking is you get that elevated antenna, as opposed to being on the ground with a 3-element antenna, for example, or even a 5-element if you're good and strong, or if you have it attached to a truck or something. But you really get that elevation off the ground, and I think that really expands how far you're detecting, which is a good benefit.
I have a comment about Perdón, ya no sé ni qué hablar. Tengo, tengo un
I'm
comentario
sorry.
acerca de
I'm going to speak in Spanish. I have a comment about the home range
como cuándo usar,
and when
cuándo
to
usar Motus, la
use
antena Motus o la
Motus antenna
telemetría manual.
or
Yo creo que
manual
además
radio
del costo,
telemetry. I
obviamente
think that
depende
besides the
de
cost,
las
it also
preguntas
depends
que
on the
tengamos.
questions
Y en
that
cuanto
we
a los
have.
rangos de hogar,
And
definitivamente
regarding home ranges,
no sé hasta qué punto
I don't know
si Motus sea una buena
if
estrategia
Motus
en este momento con
is
la capacidad de análisis
a
que
good
tenemos y
strategy
también dependiendo
now
de las
with the
herramientas
analysis
para
capacity that we
poder
have
definir
at the
esos
moment
rangos de
to
hogar.
be able to
Para
determine the
nosotros,
home
la
ranges. For
telemetría
us,
manual ha sido
radio
definitivamente
telemetry
clave
has been
para
key
poder estimar esos rangos de
to be
hogar.
able to estimate the home
Sin embargo,
ranges.
una de las limitaciones sigue
However, one of the
siendo
limitations that we have
asegurarnos de
is
que
still
tenemos
to make
tamaño de
sure that
muestra,
we
el
have
número de
a
puntos
sample size
que tenemos
or
para
a number
estimar
of
el rango de hogar,
points
porque si
necessary to
no
be able
estamos
to
seguros
have
de
a
que
good
ese rango de
estimation
hogar
of the home
se ha
range
estabilizado y
because
ha estado en la
we need to
cifra,
be sure
entonces realmente
that this home
estamos
range is
midiendo otra
stable.
cosa.
And
Digamos,
if we are not sure,
variaciones
then
del
we're
tamaño del
measuring
rango de
somewhere
hogar
else,
puede estar
something
afectada
else,
sencillamente
because a
por el número de
variation in the
puntos que
home
tenemos
range
y no
can be
necesariamente
affected
por
by the
las
number of
variables
points that we have and not
que estamos
necessarily
mirando.
because of
Entonces yo creo que
the
algo
variables
importante y
that we
que
are
es algo
looking
que es
at. So I
bastante
think that is
común en
something
los estudios
important
de
to
telemetría
highlight,
y
and that is very
ornitología,
common
que se presentan
in telemetry
los rangos de
studies
hogar, pero
because we
no se
see the
menciona,
home
se recalca
ranges,
solo
but it
cifras
is not
aparece el rango de hogar,
mentioned
no se muestran las
if
gráficas de cómo se
we
alcanzó la
if it was
metodología
achieved
y creo que es algo con lo que tenemos que tener mucho
via
cuidado
what.
porque
So the
esto
methodology
es
does not
clave
always
para
show in
asegurar que
obtaining the
estamos
home range, and I think that we have
los
to be
análisis que
careful
estamos
about that
haciendo son
because
correctos.
we
Entonces,
want to
sí,
make
las
sure
preguntas son a
that the
nivel
measurements
local.
that we're
La
doing
telemetría
are
manual sí
correct.
puede ser un poco más costosa,
So
pero
yes,
sí nos va a
manual
dar información
telemetry
a unos
is
niveles de
more
detalle
expensive, but if
que
it's
creo
going
que
to
para la
give us
mayoría de especies
information or
todavía no hemos
data
alcanzado con Motus.
at a level that is more precise than Motus,
Gracias,
then
Ana, buen
we should still
punto.
go for it.
Y como
Thank you,
mostró
Anna.
Kristen,
That's
también
a
puede ser un
great
primer paso para
point.
entender bien cómo
And like
las
Kristen said,
correcciones.
maybe this is just the first step to be able to realize what
Y
is the best
otro punto en cuanto, bueno, de
space
poner
or the best area
torres
to
y
put a
es como un
Motus
comentario que
tower.
tengo general
And yes,
y
and
también de
adding
pronto
up
no
to
sé si
that, this is
aquí
a
hay alguien
general
de
comment
Motus
that I
que
have,
tenga
and I
entendido
don't
que hay un
know
plan
if
estratégico para la expansión de
someone
la red.
here has more information. I know that
Y
there is a strategic
también me
plan
pregunto
for the
si hay un
expansion
plan
of the
estratégico
network.
para el
I am wondering
mantenimiento
if
de
there
la
is
red,
also a strategic plan for the
porque
maintenance of the network,
después de que hicimos nuestros
because
análisis para nuestro trabajo, por
after
ejemplo, con
doing
los
the
catarros
analysis for
especies,
our work
notamos que hay
with Catarrhus
torres
fusensis,
en el norte
we
de Colombia,
noticed that there are
alrededor de la Sierra Nevada
towers
Central, que son
on the
claves
north
para el
of
estudio
Colombia
de muchas especies en
and the
Norteamérica
snowy
y
mountains
esas
of Santa
torres
Marta,
ya no
which
están
are key
activas.
for
Entonces, las
species
personas que están
from
trabajando
North
con Catarrhus
America. But those
fusculatus,
towers are no longer active.
con los Blackpool Warblers o con
So,
especies, por ejemplo, nopales
for
de Santa
groups
Marta, pero con
that
especies
are
que están
working
cruzando el
with
Caribe o que
species
están
that are
atravesando la
crossing
costa de
the
Norteamérica como un
Caribbean
tipo de
or are
parada,
using the North
esta
American shore
información
as
no la vamos a
a
tener. Entonces
stopover
es
site,
importante tener,
we're not
sobre
going to have
todo
that
en Sudamérica,
information.
donde
But
la
I
red
think it's
es tan
important to
limitada, es
have,
importante
especially in
mantener
South
esas
America,
posiciones
because our network
estratégicas
is
para el
so limited that
beneficio
having
de todos los usuarios
maintenance
de la
in
red,
those
especialmente para las
towers that are
personas que están con los
strategic
tags en
is
Norteamérica,
key,
o bueno, o también en
especially
Sudamérica,
for groups that
que
are
las redes
tagging
pueden
individuals
estar
in North
usando sus sitios
America
de
or
parada
even
durante
South
su regreso
America
en la
that
medida que
are
ellos son
stopping over
probablemente.
at specific sites when flying back to the breeding grounds.
Hi, Anna. I don't know anything about a specific strategic plan around maintenance that the Motus headquarters folks are working on, but at Bird Conservancy of the Rockies, we've put up over 75 stations in the past 5 years, and a lot of them need maintenance, whether that's an antenna is bent or whether the Wi-Fi got disconnected and we need somebody to physically go out and sign into the Wi-Fi again, or the station just needs to be rebooted. And so one thing that we are working on is trying to build a series of documents that could walk someone like a station host who may or may not be very savvy with opening the sensor station and doing it. We'll walk them through the steps for here's how you reboot it, here's how you reconnect to the Wi-Fi, et cetera. And we've worked with partners in the Chihuahuan Desert in Mexico who have established a number of stations. And so one thing we're planning to do is translate those documents into Spanish as well. And so that's definitely something that we will share with the broader network. One challenge we're facing, I think, is that Bird Conservancy has a specific way that we set up our stations. And even within that, each station is very different. And so I know there's many ways to do it. So, there might not be one size fits all for documentation, but that's one need that we're really seeing because like you, Anna, I've noticed that, some of these towers are offline and I want that data for these spots. So in addition to kind of building resources to help folks go out and fix problems that we've identified, is we're also trying to establish some documents for station health checkups for our partners as well, to send them out, at least once a year or so to go and just take some pictures of the station, verify that things are working out. So yeah, I'm eager to hear what other folks are doing in terms of maintaining stations when you're far away from them physically.
I guess for us, we're lucky to have a really strong partner in program for Belize, and that we have staff pretty well trained to download data, but then check on the towers and look for any thing that may be wrong. And then Low Tech has been fantastic in kind of jumping on calls and walking the program for Belize staff, through any sort of troubleshooting that might happen. So strong local partners certainly go a long way.
Yeah, definitely. Maintaining Motus stations is a perennial challenge and something that is really important to kind of factor in when you're planning a project. I can say that one thing we are working on at Birds Canada is we have fairly recently started an initiative to both expand the network in Canada and also upgrade a number of existing stations that are kind of due for some improved equipment and technology. And one of our goals is to make those new stations and upgraded old stations super robust, so that the need for maintenance is hopefully as minimal as possible. Of course, it'll never be nothing, but the more robust you can start a station at the outset, the less maintenance, and it'll down the line. So kind of a little more cost at the beginning probably works out to less cost over the long term. And yeah, of course, as Jeff said, having good partners, relationships is super important. Yeah, and I just wanted to say thanks to all the presenters for such great and informative talks.
We're almost at the end of the hour and a half, but I just wanted to second Fabi's comment in the chat that the resources you're talking about, Jesse, sound really useful. And in the collaboration spreadsheet that we just shared and open to everyone, one of the feedback comments that we got was to add a tab for resources, because we have a tab for project collaboration ideas, funding opportunities, training opportunities. But then, yeah, the comment was to add a tab for resources. So if folks have really useful resources like that could be helpful for folks who are doing Motus or using other tracking technologies, feel free to add them there. That would be great. I don't know, does anyone else have a final comment, question?
We'll just post the link for the Motus resources and documentation in the chat here, because there's a ton of stuff within there guides on setting up stations and working with data, all sorts of things. There's a lot to sort through, and you can always reach out to me if you would like some pointing in the right direction if you're trying to find any Motus resource in particular.
Thanks, Amy. All right. Thank you everyone for attending, and thank you again so much to our 3 amazing presenters for these wonderful talks. And yeah, we'll share those resources with everyone. And we'll see you next time. Thank you all for a really awesome session.
Yes, thanks everyone.
And thank you, Claudia, as always, for interpreting.
Yes.
Thanks, y'all.
Bye, everyone. Okay, gracias. Ciao.
Thank you.